Hello. Can everybody hear me? All right. Welcome everybody to the very first CodeNeuro. Thank you all for coming here. This is a really awesome, awesome turnout of a lot of people from a lot of different domains, and we're super excited to have everybody here. I want to start by just saying thank you to a couple people. I want to thank Genelia, which is where I work, for hosting and sponsoring this event. I want to thank Databricks for sponsoring the videography. So we're going to have videos from this event posted online for anyone who wasn't able to be here. I want to thank the co-organizers, Michael Broxton and Nick Sofenrue, who you will see present today, and also Eric Troutman and Logan Grosnick, who were super helpful in putting this thing together and making it all happen. And most of all, thank all of you for coming, and we're really excited to have you. To give a brief introduction to this event and why we're here, I'm going to start with a quote by our president, who is not a neuroscientist and I don't think is a coder, though maybe he does. But he, I think, put really eloquently, in some ways, why we're all here. He said that as humans, we can identify galaxies light years away, we can study particles smaller than an atom, but we still haven't unlocked the mystery of the 3 pounds of matter that sits between our ears. And I basically think this is true, and it's part of the reason that we're all here. The brain, in general, is a fundamentally mysterious thing. And it's almost surprising how mysterious it is, because so much of what we do with our brains feels so effortless. Think about how you found your way to this venue, how you recognize maybe old friends, or how you learn the name of someone you just met and hopefully remember their name tomorrow morning, unless you stay too late at the bar. This is so easy for us. It feels so simple. And yet, our brains are doing this amazingly complicated thing to do all of that and to make that possible. And that's all true for humans, but this is also true of simpler animals. Everything from a monkey to a mouse to a fish to a fly. Animals do all kinds of complicated behaviors. You're going to hear about some of them today. And they do it with a brain, and we don't really fundamentally understand how that works. And I think that's fascinating. So maybe we're here because we want to know how the brain works, but the question is, why are we all here right now in this space? And I think the reason for that is that right in this moment, 2 very exciting things are happening. The first one is what I would really call an explosion of technologies, and really in many ways a paradigm shift in terms of our capabilities in neuroscience and in experimental neuroscience for monitoring and manipulating the nervous system. And these are things you're going to be hearing about today, really from the cutting edge. Methods for large-scale electrophysiological recording from the brain, electrical activity, optical methods to record from huge populations of neurons, in some cases, like the zebrafish, to record the entire brain. Methods to perturb the nervous system, to use light to activate or inhibit individual neurons. And also methods for large-scale anatomical characterization, to map patterns of connectivity. We basically have unprecedented access to this incredibly complicated and mystifying thing that sits between our ears. Now, we need to understand it, and these methods are generating huge amounts of data and lots of very complex data. So it's large simply in the sense that the raw data is really, really big, and we need infrastructure and systems and technologies to work with it, but perhaps more importantly, it's also really complex. And as I think everyone here appreciates, or hopefully appreciates, understanding data is different than processing data. And both of these things right now in neuroscience are an enormous challenge, and I think a really exciting challenge. The other thing that's happened over the last several years, and is also to some degree, I think, exploding right now, is advances in computing technology. Things like modern languages that are meant for statistical computing and scalability. Systems for distributed computing. Spark, for example, which is something that you're going to hear a lot about today. New techniques and algorithms for machine learning, for extracting information from often very complex data. And also strategies for interactive visualization, which I think is enormously exciting and has a lot of relevance for the things we do in neuroscience. So these 2 things are happening right now, and I think have reached a certain level of momentum that I'm extremely excited about. And there's an enormous opportunity to start bringing them together. And certainly that has been done to some extent by others thus far. You will hear about many examples of that today at this meeting, but certainly in my own experience being at the interface of these worlds, there's a huge opportunity to do more of it and to really try to bring together those of us that are primarily doing neuroscience and those of us that are primarily doing data science, data engineering, and ideally those of us that are somewhere in between. And for us all to work together on what really are fundamentally, I think, common problems. The thing that most of us, I think, have in common is that actually we do a lot of the same things and we think about a lot of the same things. We all try to, or at some level have to, process data, analyze data, visualize data. So this is something I think everyone in this room probably has done. We all kind of are working on ways to find patterns in complexity, whether it's the complexity of a bunch of neural recordings or user data from a website or anything in between. There are patterns and we want to find them and we want to understand or reveal the simple deep truths that underlie the observations that we make. And perhaps even more deep and more fundamental, we want to understand how systems work. The brain is a big complicated system. There are lots of other big complicated systems. And how to understand them, how to make sense of them, I think is a fundamental challenge that really brings a lot of us together regardless of how we got here. At the same time, there are a lot of challenges, I think, to bringing these worlds together and for integrating techniques and approaches and perspectives from different domains. And there are challenges on both sides. On the side of neuroscience, and in science in general, I think an enormous challenge that we need to deal with, and there are a lot of people, I hope some in this audience, are making efforts in this direction. We need to standardize what we do and we need to modernize what we do. A lot of neuroscience is based on work that happens in small labs using proprietary tools with nothing made available or shared. And there's an enormous opportunity if we were to do that and do more of it. And a lot of people are thinking about that direction. And an event like this hopefully is a chance to continue those conversations, evolve those conversations. How cool would it be if the data we were generating in experimental neuroscience were trivially accessible in an organized way for someone who knows nothing about the brain to look at it, try some new algorithm, try to understand it, form a collaboration. This is, I think, a huge opportunity for us, but it will take work. We also, in general, need to coordinate our progress in neuroscience. So many of us are doing similar things, and we would really benefit from coordinating, but because of the way a lot of work happens now, that doesn't happen. So again, I think this event is an opportunity to start talking about how we can modernize our tools and modernize the ways in which we can collaborate and coordinate. I think a challenge particular to neuroscience is how to move beyond just basic observations. That's true throughout what we do. But in particular, in terms of collaborations, for example, between those doing neuroscience and those doing data engineering or data science, how do we not just start a collaboration but maintain it? How do we forge connections and keep them going? So I hope today and tomorrow is an opportunity to at least start a bunch of cool ideas and cool conversations, but it will take work to keep them going. On the other side, I think there are challenges that are achievable and can be met, but are also important and somewhat difficult. One that I've certainly experienced is just the problem of translating expertise. I think there's a lot of ways in which we all kind of speak the same language, but we end up using very different words and very different terms and are often talking about basically the same thing. And it will take some work, but I think something we can achieve is ways of translating and connecting despite working on superficially different things. There's also the challenge of just appreciating and learning some domain specificity. Often in neuroscience, we work on particular problems that have particular biological relevances, and it can be sometimes challenging to know how to sort of delve in and start working on something without forging or having some of that understanding. So that's something, again, we can work here and try to bring together and teach one another what we're doing and introduce these ideas. And finally, knowing the questions. I think fundamentally what I find most exciting about doing neuroscience is that most of the problems are pretty ill-defined. You're trying to find structure and understanding in this complicated piece of biology. Often it's very unclear what the answer is even going to look like. And that can be an enormous challenge for just starting and getting your feet wet in the various analytical challenges we face. But it's also, in some ways, what's most exciting about it. And I think, again, hopefully, this event is an opportunity to start those conversations and start those collaborations.